Salam. Uh, I hope you are well and in a good health. Uh, okay, this is the first session of the class of the distributed database or advanced database. Uh, okay, first of all, um uh, what do you prefer to talk in Farsi or English? What do you prefer? English, okay, okay, thank you. Okay, okay. I'm going to talk in English in this class. Uh, Unfortunately, only four students are in class. Okay, this class has more than this number. Okay, more than 10 students are registered in this class, but unfortunately, only Uh, four students are in class. Four or five, I think five students. Yes, five students are in class. Uh, okay, today uh, I'm going to talk about something about uh, the infrastructure of advanced the database. You learn the concept of database in the previous degree, in the bachelor degree. You learn some definition, some module, the responsibility, and some other things about the database in bachelor degree. Uh, and now, in this term, we want to talk about the advanced database. Okay, so the uh, you should to know the principle and the concept of database. Okay, uh, and in this course we want to talk about some other modules and the important modules of advanced database. uh, Usually the infrastructure of advanced database is distributed systems. Distributed systems. Distributed systems, or DS, is a collection of some computers which are connected to each other through the high-speed LAN, through the network, uh, uh, and and the data are stored in some machine instead of one machines. Okay, so we need appropriate uh, operating system, DBMS, or database management system, because the data is spread between some machines. And okay, so a spatial system is needed to manage the data which are stored between some machines. uh, uh, Alaikum assalam. Zia. Okay, Hassan say that I can not understand. Yes, um, because of the internet and internet connection, especially um, especially for you, for some students which are in Iraq, okay, so only I use only the voice and the microphone, not webcam. Uh, okay, so you can hear my voice. Uh, you know, image and image processing has a need uh, good internet connection. Okay, and okay, it's clear. I think it's clear for you. Yes, Mustafa, before start class, I start the record. Uh, I start the recording, okay, and so after the class, okay, after 1 or 2 days, you can download um the recorded class. Okay, you can download the appropriate file from the Darsa website. Okay, but you must need 1 or 2 days. After that, you can download the recorded file. Uh, okay. Any other question? Any other discussion? Okay, I say you the infrastructure of a advanced database is distributed system, and now I am going to share uh, the appropriate file about the definition of distributed systems. Okay, please let me to upload appropriate file. Uh, okay, you're welcome, Mustafa. Okay, this is the first file and the first presentation for the advanced database. I say you um, the infrastructure of advanced database is distributed systems. Okay, no, I'm going to talk about the distributed systems. I'm going to define these systems and some features, some characteristics of these systems. Okay, what do you know about distributed system? Do you have any information and knowledge about the distributed systems? Do you have any information about these systems? Okay, enable I enable the microphone right for participant in this class. Okay, if you want, you can talk, and uh, it can be so better that have some conversation in the class. Uh, I prefer to have it to have a class uh, with some conversation, some discussion in the class. Okay, if you have any question, any knowledge about the distributed system, um, I'd like to hearing your knowledge or your information. Okay, Mustafa, I can send this file for you. Uh, okay. I send the distributed system file via this Adobe Connect via this software. Can you receive it? Did you receive the distributed systems, the distributed system file? Did you receive by POTS and by the Adobe Connect? Okay, that's good. And also, I can share this file in the portal in the Darsa website. Okay, I'm going to upload in the. Okay, this file, the distributed system, is uploaded in the website Darsa. Uh, Also, you can download this file from the Darsa. Okay. Uh, okay. What is the distributed systems? Okay, I want to talk about the distributed system, which is the infrastructure of advanced database. Distributed system is a piece of software that ensure that, okay, A DS or distributed system is a collection of independent. In the collection is a collection of independent computers. Independent computers appears to its users as a single coherent system. Yes, so you can see two important characteristics of for the DS. It use independent computers, and also these systems appears to its users as a single coherent system, Okay, so it need to use appropriate software, which is called the middleware. This middleware is installed on each systems. Okay, so this the shared software between uh, between all machines. Okay, so again, I can say there are two aspects in this definition. There are some independent computers which are connected through the network, through the it can be high-speed LAN, and another aspect is it appears to its user as a single system. Okay, so it use appropriate software which is called middleware, which installed on the operating system. Each computers can use its own hardware resources, its own operating system, but the middleware can provide a single query system for all users. Okay, so you can see in this figure that the middleware is installed on the local OS, and after that the application can send the request to the middleware, and the middleware is responsible to manage all requests from the application and provide appropriate hardware and software for applications. Okay, what is distributed systems? Uh, is a collection of independent computers that appears to its user as single coherent system. It consists of multiple computers that don't share memory, Uh, each computer has its own memory and runs its own operating system, and the computers can communicate with each other through a communication network. In this slide, two different figure of a distributed system are demonstrated. And you can see some uh, aspect of DS in these two figures. A distributed system organized as middleware. The middleware layer extends over multiple matching and offer each application the same interface. Okay, what are advantage of distributed systems over centralized systems? Okay, you can compare distributed systems and centralized system. There are two types of systems, which are some different features. And okay, so now I want to talk about the advantage of DS over centralized systems. First is economics. A collection of microprocessors, the DS is a collection of microprocessors. And a collection of microprocessors offer a better price per performance than mainframe. Mainframe is a centralized systems, which can be costly, uh, and okay, a collection of microprocessors offer better price per performance than mainframe. You know, the mainframe is costly and cannot buy by individual users. Usually, some organization, company, university can buy the mainframe, but it's so costly. And okay, in comparison, we can say the microprocessor, the collection of microprocessor can offer better price per performance than mainframe. A low price per performance ratio is cost-effective way to increase computing power. Yes, with okay, this is uh, a method to increase the performance of a systems of distributed systems to increase the computing power. Another advantage of DS is the speed. And distributed systems may have more total computing power than a mainframe. Yes, because we have some matchings, and so at each moment, uh, uh, some instruction, many instruction according to the number of matchings can be executed at each moment. So, uh, so I can say distributed system may have more total computing power than mainframe because in overall we can say the number of instructions which can be executed by a distributed system is more than the number of instructions by a mainframe. Okay, so enhance performance through load distributing. We need to distribute the load between some matches in DS. Yes, we need to distribute the load between some matches. Okay, so we need to use appropriate software, appropriate middleware uh, to distribute the load between some matchings and manage the work, manage the load and request. Okay, uh, so by using this technique and methods, we can increase the performance, the overall performance. Another advantage of DS is inherent distributions. You know, uh, some applications such as supermarket chain. This application is inherently distributed because the supermarket is spread. It can be spread over the city or the I don't know state, country, sometime in the world, and so these applications are uh, inherently distributed. Okay, so um, um, it's better for this application to execute on distributed systems instead of executing running on the mainframe because if there is a mainframe, okay, all requests must be sent from a different location, must be sent to only one systems. Okay, so this type of system need to use appropriate networks, and sometimes some features such as bandwidth, such as delay. Okay, these are uh, uh, depend to the systems. Okay. Ibrahim say that sharing of resources. Yes. Yes, this is another um, advantage of distributed systems. Yes, and also yes. You can some other advantage of distributed system are remain, and I'm going to talk about them. Yes, I think scalability is another advantage of distributed systems. Reliability is another advantage of distributed systems because you know if one matching crash in distributed systems, okay, other matchings can continue the education, the execution, sorry, and okay, so if one matching crash, the system as a whole can still survive. Higher availability and improved reliability are the advantage of distributed systems over centralized systems. Ibrahim say, uh, for example, resource sharing. Yes, resource sharing is another advantage of distributed systems. Some important resource, some appropriate resources such as uh, uh, a pre-neural likes a color printer, expensive uh, pre-neural like color printer can be shared between some users through the distributed systems. Another advantage is data sharing. Data sharing, these systems, DS, allow many users to access to a common database. Yes, to a common database. Data is shared between some users. Uh, incremental growth. Okay, during the time we can increase the number of matchings, and okay, by increasing the number of matchings, the computing power can be increased in a small increment. Okay, it's called modular expandability. Some applications such as email, chat, okay, need communication. And also, okay, so by using distributed systems, we can enhance human-to-human communication. Flexibility. Um, what are the goals of DS? Some goals of distributed systems: make a resource available, distribution transparency, openness, and scalability. Okay. We want to talk about them. First, what is distribution transparency? It means how to achieve the single system image. How to achieve the single system image. Okay, I talk about them some previous slide. I say we need to use the middleware. Okay, so the middleware uh, uh, should provide the distribution transparency. Okay, how to achieve the single system image, i.e., how to make a collection of computers appears as a single computer, as a single computer. Okay, so the DS should be viewed as a single system for all users. Okay, it's uh, it's, it is not depend uh, to the location of the users, to the matchings, and okay, all user must be see the system as a single system. Okay, and hiding all the distribution from the users, hiding all the distribution from the users. Okay, uh, which characteristics um, should be hide from the users? Okay, transparency uh, must be exist in some uh, details. Transparency in access. What means uh, hide difference hide differences in data representation. High differences in data representation, and how a resource is accessed, and how a resource in access. Another uh, another feature is location. Hide hide where a resource is located. Again, hide where a resource is located. Okay, so the location uh, is not important, and user can send to use a resource without any knowledge about the location. It can be on its uh, own machine, or can be in another machine uh, in the DS. Migration. Hide that a resource may move to another location. Migration it means that migrate, or a resource can move to another location. So uh, the resource, especially the data, because in this course I'm going to talk about the data and data distribution. Okay, the data can move to another location in advanced database. Okay, so um in transparency, in migration transparency, hide that a resource may move to another location. Relocation. In relocation again, a resource may be moved to another location, but in relocation we want to hide that a resource may be moved to another location while in use. While in use. Okay, the differences between the migration and allocation is in this part. Uh, in migration, the resource can move to another location before uh, um they using, but relocation in relocation, um, a resource may be moved to another location while in use. Replication, hide that a resource is replicated. This is a very important challenge, and I'm going to talk about this challenge, especially in the database, uh, in some next sessions. Concurrency, high data resource may be shared by several competitive users. Concurrency high data a resource may be shared by several competitive users. And failure, yes, hide the failure and recovery of a resources. The failure can be occur for any resource in DS. Okay, so in transparency, uh, the failure must be hide from the users, and the failure and recovery are hide from the users. It can be done. It can be done automatically or by the uh, uh, owner, well, by the resource owners, but it must be hide from the users, from the usual users of this. Okay, another goal of DS is openness. An open, an open distributed system is a system offers services according to the standard rules that describe syntax and semantic of the services. Okay, and this system, the OpenDS, it can interact with services from other open systems. Okay, so the open systems, the open distributed system must should be used uh, standard rules uh, to describe and define the services. Okay, so some syntax and semantic should be specified for these systems, and according to the special syntax and semantic, our services must be provided for each computer, for each machine, for the systems. And okay, so this system can interact with other operating systems by using uh, uh, these rules, these standard rules. Uh, this is usual in the internet. If you uh, utilize or something, if you hear something about the web services, in the internet, uh, the web services can be offered by many organizations, many company and websites. These web services are uh, provided, are developed by the standard rules. And okay, so the different um, uh, software, different application in the internet can use the services, the web services which are provided by any uh, company, an organization, any users. Uh, okay, because these are use a standard rules to interact with each other. Uh, One important example of openness in this system is, in computer networks, standard rules govern the format, content, and meaning of message sent and received. This is a good example of using standard rules. Uh, Mohammed, I cannot speak with Arabic language. If you want, you can choose one student, one of your classmates, to translate to Arabic. Okay, if uh, okay, if there is any candidate for translator, okay, uh, Muhammad, right? Uh, yes. It's my appreciate to have a good translator in the class to translate from English to Arabic. It's my appreciate. Okay, if uh, there is any candidate, okay, uh, it can um, send a message for me and declare me about this position. Mustafa, right, doctor. There is no student for translation. Yes, I think because of the number of students, because only 5 students are in the class, and is it possible to get a material file? Uh, well, I cannot understand what's the meaning. Material file? About what? Which file is material file? Can you write a PDF file? Yeah, I uploaded the PDF file. Yes, Mohammed, I uploaded the PDF file in the Darsa website. You can download it. Okay. Another goal of distributed system is scalability and okay. Uh, what is the scalability? What's mean of scalability? Many developers of the modern distributed systems usually use the objective scalable without making clear why their system actually scales. Scalability is a very important aspect of any software and application. So what is the scalability? A system is scalable if it remains effective when there is a significant increase in the amount of resources and the number of users. Okay, this system is scalable. It should be remain effective. When there is a significant increase in the amount of resource and number of users. Some uh, important example of scalability is internet, Google. Yes, there are I know that you know the internet and Google, and in the internet the number of user and service has grown enormously, and uh, fortunately it's remain effective. And another example is Google company and Google uh, softwares. Google scale over the years uh, to handle billion queries a month. Expected query time uh, 0 0.2 seconds is very uh, uh, good I can say, or a good feature of the Google. So is it's scalable, and their performance is good, and the system is effective by increasing the number of users over the year during the years. And scalability denotes the ability of a system to handle an increasing future load. Denote the ability of a system to handle an increasing future load. Mustafa, right, Doctor, please. Is it possible to merge and change two lecture by the university to get the most number of students? Just change the lecture time to get the student to translate. Okay, which time, Mustafa? What do you think? Which time is better for this class? Which time is better? Till I have another class at 12 o'clock. Okay, I cannot transfer to this time. Mm, uh, okay, um, I must to talk to some some manager uh, in the university and talk about this challenge. Yes, the number of students is lower than the threshold. Okay, it's okay. inshallah, I will talk to Dr. Nico Adam or other uh, manager in the university to talk about this challenge. Okay. Yes, Ibrahim. Ibrahim, right. The abundance of data, moment by moment, is an oppress and expansion. Okay, so uh, another one important goal of distributed system is scalability. The scalability should be exists at least in three components: uh, size scalability, geographical scalability, and administrative scalability. Size scalability is the number of users and or process. Uh, Geographical scalability, it can be calculated by the maximum distance between the nodes, usually when the application is used by the user from different country, different location, and the number of administrative domains. Okay, it's called the administrative scalability. Okay, I'm going to talk about these components. How to make a system scale? Before talking about these methods, uh, I am going to say some obstacle for achieving size scalability. Size scalability, is very important because we want to increase the number of users, the number of process over the time. Okay, so some obstacle when we use the centralized solution, some obstacle uh, or for achieving some obstacle exists for achieving size scalability. Okay, for example, the centralized services are not scalable because okay, for example, when we use a single server for all user, a single server for all user, each server uh, has its own performance. Uh, okay, so when a system is used, for example, by 100 users at each moment, okay, this system can be uh, present, appropriate, and good performance. But increasing the number of users from 100 to 1000, okay, this is a challenge for centralized services because this system is appropriate for 100 users, not for example, 1000 users. Okay, so using centralized services uh, 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 is not scalable. And okay, another concept is centralized data. Okay, one example. a single online telephone book. A single online telephone book. Okay, this is very important for us because this is related to database. Some database are configured to store in one node, in one machine. Okay, all query and all requests must be sent to one machines, and this machine must process all requests. Okay, so by increasing the number of users, or by increasing the number of queries, okay, the system cannot present good performance. Okay, so this system is not effective, and is not scalable. Okay, another uh, concept is centralized algorithm. Some algorithm are centralized because okay, the algorithm designer, uh, many algorithm designer prefer to uh, uh, write the centralized algorithm, but this algorithm uh, usually need to run on a single machine, on one machine. Uh, okay, for example, one algorithm routing. Uh, this is one algorithm in the network. In routing. Uh, each node, when a node receive a request, uh, receive a message from the network, in routing algorithm, the node must be find appropriate path to send the message uh, to the receiver. Okay, so each node need to use appropriate routing algorithm. Okay, so if the algorithm is a centralized algorithm, okay, at each time uh, the uh, algorithm, this algorithm, routing algorithm, must be obtain all appropriate information from the other nodes. Okay, so this is costly algorithm, and okay, so usually in the internet and the internet world, we need to use uh, a distributed algorithm, not centralized algorithm. Again, I must say the centralized algorithm needs the complete information. Okay, so all information must be obtained by each node to decide about the appropriate path to send the message to the uh, determined destination. Uh, okay, some characteristics of decentralized algorithm. I say you one example of algorithm, which is the routing algorithm. Okay, some characteristics of decentralized algorithm. Okay, I say you that centralized algorithm is not scalable, and okay, so the designer must be uh, uh, write uh, decentralized algorithm. Decentralized algorithm in decentralized algorithm, no matching has complete information about the system state. No matching has complete information about the system state. Matchings make decisions based only on local information. Matchings make decisions based only on local information. Failure of one matching does not ruin the algorithm. Failure of one matching does not ruin the algorithm. An algorithm can be uh, a continuous education. Is execution, sorry. And there is no implicit assumption that a global clock exists. There is no implicit assumption that a global clock exists. These are these four characteristics is belong to decentralized algorithm. Okay, wait and rest for 5 minutes, and after that I will continue this concept. Okay. Now we can have a break time. Have a break time for 5 to 10 minutes, and after that, inshallah, I will continue. Okay, I come back to the class, okay, after breaking time and okay, any other question? Any question? Are these risks in distributed system? These risk? Thank you, Muhammad. Okay, some techniques. These are some characteristics of decentralized algorithm. Okay, and okay, you know, scalability is important. It's a goal of distributed systems. Okay, how we can achieve the scalability? Uh, some techniques um, are introduced for scalability and for scaling. Okay, I'm going to talk about some techniques uh, for scaling. Um, one technique for scaling is distribution. Is distribution. It means partition data and computation. Okay, data or computation or both. Partition data and computation across multiple matching. Partition data and computation across multiple matches. Okay, for example, the computation can move to clients when we use Java applets. Using decentralized naming services, DNS. Okay, I'm going to talk about it, and decentralized information system or triple W or internet. Okay, you know, uh, these are some techniques for partition data and computation over a multiple match. I know, Muhammad. I know. Uh, okay. Uh, what do you mean? Uh, okay. Are you going to talk about 5 minutes? Okay, 5 next minutes. Okay. After that, I will finish the class. Okay. Uh, Inshallah, in the next week, I'm going to continue this concept, inshallah, in the next session. All the students are in class, will participate in the class, inshallah. Thank you, Muhammad. Thank you so much. Uh, okay, one technique for distribution is move computation to clients. In this figure, you can see these techniques. Okay, in the figure A, you can see the data is gathered in the client side, and after that the data are sent to the server, and at the check form process, uh, thank you, Mustafa. Thank you. Uh, inshallah, inshallah, in the first time that I can, I will go to the Karbala, inshallah. It's my appreciate to go to Karbala and okay, but unfortunately because of the coronavirus and also some other things. Okay, I cannot go to the Iraq nowadays, and inshallah in the first time, the first position that I can, I will go to the Iraq and will visit you, inshallah. Uh, thank you, Zia. Thank you so much, all the students. Thank you. Uh, I'm going to go to uh, Iraq and especially in Kerala as soon as possible. Um, okay, thank you so much. Okay, what is the difference between the check form, which is done on the client side or on the server side? In the figure A, you can see the check form um, is done in the server side. Okay, so all data are all appropriate data must be sent to the server, and the check form is processed in the server side for all user. Okay, so for example, if 100 clients are connected, our 100 clients are connected to the server. Okay, so the server must be uh, perform must be performed the check for process 100 times, because the server must be perform the check form for each client, for each request. But in the figure B, you can see the check form process is performed on the client side. What's mean? Um, okay, so the load, this process is spread between all clients, and it's not to execute to perform on the server side. Okay, so by move computation to clients, we can spread the workload between some machines. Okay, this is one technique for scalability. Move computation to clients. The clients, instead of sending the information to the server, each client can execute, can perform the check for, and after that, the result can be sent to the server side. This is one method for scalability, which is provided by Java Applet. Another method for distribution is using decentralized naming services. Okay, Muhammad, right? The second choice is the best because it is fastest to process and few error and data is not lost. Yes, Muhammad. Yes, uh, it's correct. It's correct. Decentralized naming services is another method for scale for distribution. You know, a DNS server is a computer server that contains a database of public IP addresses. Yes, the DNS server is a computer server that contains a database of public data addresses and their associated hostname. You know, there are some IP addresses for each hostname. For example, in this slide, uh, The www.livewire.com is a host name, and these IP addresses is belong to this host name. These information are stored in the DNS server. Okay, and the DNS server is responsible to translate the IP address from the hostname. Okay, these data are stored on the data server, and in most cases serves to resolve or translate their common names to IP addresses as requests. It's in more uh, easy to understand term. A DNS server on the internet, a DNS server on the internet server is a device that translates the host name you type in your browser to the IP addresses that is really is. Okay, it's the responsibility is a DNS responsibility. Okay, but these information are not stored in one machine, and the names are hierarchically organized in a tree of domains that is divided into several zone area. Okay, so each the node of this tree can be uh, stored in different nodes. Again, each node of this tree can be stored in different matchings. So, according to the um geographical uh, domains and geographical requests, according to the number of uh, request number of query. This information can be stored in some machines. This is one example of using distributed database because these are a content of many data or many information, and these data are used by many users over the world because all users over the world write the host name in the browser, and this host name must be translated to the IP address. Okay, so this is a huge process, and this information cannot store only in one machine. This information must be spread over some machine over the world, and okay, some many machines over the world as DNS servers are responsible to translate the host name to the appropriate IP addresses. Okay, this is another technique for uh, distribution. Okay, it's enough for today. If you have any question, I'm hearing. If you have not any question, okay, we can finish the class now, and inshallah, in the next session, I'm going to continue this concept. Any question? Any question? Okay, thank you all students. Thank you for participating, and have a good day. Have a good days, inshallah. التماس دعا and خدا حافظ شما، خدا نگهدار شما انشالله. Bye for now. خدا حافظ شما، خدا نگهدار.